I don't have a code name. All right, here we go. This is 6.2, part 2. All right, listen very carefully. This is going to get complicated quick. All the answers go from 0 to 2 pi. When you're given a restricted domain and you still do it exactly the same, okay? In this case, I would let theta equal 3x minus pi over 4. You still do it the same. The only thing is you add one step to your answer from the problems we did yesterday and the problems we just talked about in homework. You add one step, okay? When you do that, you have sine of theta equaling 1. So that means theta equals pi over 2 plus 2 pi n, okay? Again, not difficult. If you did all right yesterday, you should be fine today. And if you understand the general solutions, you should be fine also. So I'm going to substitute this back in for theta. 3x minus pi over 4 equals pi over 2 plus 2 pi n. Now you have this equation. Remember, the whole idea is to solve for x. X has to be an element of the set 0 to 2 pi. Okay? Remember, a bracket means it can be 0. A parenthesis means it can't be 2 pi. So my first order of business is to solve for x. The second one is to generate all my solutions from 0 to 2 pi. And I mentioned this yesterday in computer science. It's really easy to write a loop, and that's what you're doing is you're writing a loop to generate these solutions. So first thing is you add pi over 4 to both sides. 3x equals, and you combine like terms. So if I add pi over 4 to both sides, a half plus a fourth, everybody thinks I know is 3/4, okay? Plus 2 pi n. Now you divide every single term by 3. When you divide by 3, you have x equals pi over 4 plus 2 pi over 3 n. Okay? That's where we worked at it from yesterday. Today, now I have to generate all these solutions. So if I choose n to equal, remember n has to be what type of number? An integer. Integers are positive and negative whole numbers, including, well, positive and negative whole numbers. So, and also 0, of course. If I let n equal 0, that means one of my solutions is going to be pi over 4. Okay? N equals 0 gives me that solution. What about if I pick -1 for n? That would go past 0, wouldn't it? It'd be a negative answer, and that can't happen. If I pick n equals 1, I get pi over 4 plus 2 pi over 3. Well, not easy to figure out. That'd be 3, 8, 11 pi over 12. That would work. There's no way you can wing these problems. You get all the factors, solve for it. Remember in some of them you had 3 equations? I've seen problems where there are 25 different trig solutions to the same equation. Are you going to get there? Probably not, but it's not uncommon to have at least 3 to 7. If I put in 1, I get another one. If I put in n equals 2, that means I'm putting the number 2 in for n, multiplying it. So I take pi over 4 plus 4 pi over 3. That gives me 3 and 16, 19 pi over 12. Is that less than 2 pi? Sure. 2 pi or 24 pi over 12. So I'm still in good shape.
Can you still go up by 8 pi over 12?
Yeah. If I go up by 8 pi over 12, that's 27 pi over 12. Is that too big? Yes, it is. So those are my 3 solutions. Okay? So you're doing the same thing you did yesterday, except you're adding this step of actually putting numbers in for n to generate specific solutions in the unit circle. Okay? How'd that go? Because I'll tell you right now, that's considered a very high-end trig problem to work with. Okay? I mean, you have a phase shift, you have a vertical shift, you have a change in the period, you have all that going on, and you're trying to find the x-intercept, so to speak. Okay? Oh, that was pretty good. Any questions? Yeah, in calculus, we do it a different way and we come up with the same answers. So you're doing it kind of like, not the long way, but a different way. Let's move on. Very exciting. Well, this one doesn't look hard. I say we nix it and move on.
No, we should do this.
Well, okay.
If it's easy, then we'll fly right
All right, we'll fly right through it. How you doing? All right. Remember, we're going from 0 to 2 pi on our solutions. Well, we did one like this on our homework check. Remember? 2 cosine of t plus 1. Set the factors equal to 0. Don't take factors and multiply them out. You want a factor to set equal to 0. And you have cosine t plus 1 again equals 0. So, let's see if we learned anything. What do you do next? Yeah, set each factor equal to 0, see if you can get solutions. Because don't lose factors, they're too valuable. Cosine t plus 1 equals 0. Oh, I need a 15-minute call, I think. Are we getting close? I think so. Cosine t equals negative 1/2, and cosine t equals negative 1.
What are we going to have a 10 for 10 on?
I don't know. 6.1, the identities.
But you took a grade on it.
Okay, we'll see what happens. Now, on this one, do I need the plus 2 pi n for my solutions on this one?
No.
I don't think so, because you didn't do any substitutions. It's just a plain old-fashioned cosine t negative 1/2, cosine t negative 1. So I think you can get those without any fancy general solutions. So on this side, you have the set of negative 1/2 would be, what would that be, Kaylee? Where's the 3?
No. You're factoring it.
Where does cosine of which angle equals negative 1/2? No, she set you up for failure. 2 pi over 3. And what else? 4 pi over 3. Good. And where does it equal negative 1 at? Pi. Got 3 answers. She got set up twice. All right. Nice work, everybody. All right. Feeling better? Good. All right, we're moving on. I want a tough one. Finish up today.
Super hard. Like,
This one looks super hard?
yeah.
Wow.
Actually, I don't know where to start on that one.
You know where to start?
You changed it.
Let's do this one.
Yeah.
Let's call on, whenever we have a problem, who do we call on?
Sam. Sam.
All right, E. Tangent plus sec equals 1. What do I do? What? You can, I guess.
What would you do?
Me? I don't know, I'd have somebody else do it.
Sounds like what?
Sine theta
We're not going to do this. It's too much.
plus 1 over cosine theta.
How is tangent?
I'm not done. Equals 1.
We're done.
No.
Can you add them? I mean, I know you can't, but should we add them?
Sure, you can add them. So you have sine theta plus 1 over cosine theta equals 1. Now, before I do this next step, before I multiply it,
Like cross products?
like cross product. There's 2 ways of doing this. I think the safest move is to subtract it and get a common denominator. The problem is I think I know what's coming. And I don't know how I'm going to go that route, so I'm trying to think of something else.
Yeah. Just take your time and do it the easy way.
There is no easy way. There's just different ways. Okay, first of all, theta can't equal pi over 2 plus pi n, right? That's where tangent and secant are undefined. Yeah,
Okay.
that's where they're undefined. So we got that. We threw those out. Now, Alex, what do you think? Sam? E?
Wait, is secant 2 pi then?
Yeah, but since it goes like this, we're fine. We need some guidance. Michelle had her hand up. What did you have, Michelle?
Could you change the secant into square root of 1 plus tangent squared?
Ooh, see, I thought about that, but that brings in that big old whopper of a square root sign to deal with. I think we're just going to do this one the old-fashioned way. Yeah. I'm thinking of Mr. Walken when I'm doing this.
Oh. He's not that old, is he?
Oh, yeah, older than dirt. All right. In fact, he is older than the dirt that's on that softball field. Guarantee it.
Well, that's good. You wouldn't want somebody playing on a really old field to get injured.
All right, no, she's still a class spokesman. All right, we're moving on.
How the heck did you get there?
Me, 1 is the same thing as cosine over cosine.
Oh.
All right? 15 minutes, that's not enough time to do this problem. I'm spinning my wheels.
Time to do this problem?
Wait a minute, Hannah's got an idea. You raise your hand. What is it? Oh.
That's what to do though.
What do you do?
Oh,
Well, I could do this. Oh, we aren't skipping it. All right, so I can cross multiply and get down to here. It's what?
No, do you guys want to do it?
What's wrong? All right.
You should just tell them that we're not taking it.
No, I'm going to square both sides.
yeah.
He looks across the slide.
Okay? I don't know, I'm going to have to look this up in student solutions. So I square both sides. Sine squared of theta minus 2 sine theta cosine theta plus cosine squared of theta equals 1. See, usually you don't do stuff like this till calculus. That's why I'm a little wondering what's going on. All right, sine squared minus 2 sine cosine plus cosine squared equals 1. Does anybody see how that helps?
Equals 1. Sine squared plus
Yeah, so you have 1 minus 2 sine theta cosine theta equals 1.
oh,
So I subtract. So I get negative 2 sine theta equals 0. Oh, sorry, 2 sine cosine. That's my next step. I'm getting rid of that. And then I set both factors equal 0, right? So negative 2 sine theta equals 0, or cosine theta equals 0. Can cosine theta equal 0?
wait.
At the top, we took that out.
Oh, yeah.
Yeah, cosine can't equal 0. So there's no solutions here. That means the only solution is when sine of theta equals 0. Yeah, so it's going to be 0 pi, and it can't be 2 pi. Anytime you square both sides, you have to check your answer for extraneous solutions.
How can it be
Yeah?
Yeah, he wrote 0.
Let's go and find out. Yeah, but the 0 had a bracket on it. The 2 pi had a parenthesis on it. So what's the tangent of 0? That's 0, right? Secant of 0 is 1, so that works. And what about pi? What's the tangent of pi? 0. The secant of pi is negative 1. That doesn't equal 1, doesn't it? So pi is out. 0 is the new solution. And pi came from squaring both sides. That was a whopper. Yeah.
I told you it was hard.
Because if cosine theta equals 0, that makes secant undefined. Because secant is 1 over cosine. Okay? Wow. That was so much fun.
We're all I'll jump in for that looks awful too.
That was a piece of cake.
How are we still supposed to do it?
Good, 10 minutes. Let's do one more. I want to feel good about this. Oh, sure you can. Ready? Sine of x. You have no faith. Sine of x plus cosine of x, cotangent of x, minus cosecant of x equals 0. Oh, that's hard.
No, it's not.
I didn't see the cosecant there. I thought it was 0. Sorry, my fault. All right, so how do we do this one?
Would that be cosine squared?
I would like to help you.
Plus cosine squared over sine minus, oh, this one, oh, I think I see. Yes, Abigail? She's itching to say something.
Multiply by sine.
Yeah, I got your common denominator right here. So I have sine squared plus cosine squared minus 1 all over sine of x equals 0.
Equals 0.
I know. 0 over sine of x equals 0.
No solution.
Oh, contraire, mon frère.
What?
It's all theta between 0 and 2 pi except 0 and pi, right? Sine can't equal 0. Can it? No, it can't. The sine can't equal 0. It's on the bottom. Because sine of pi is 0. 0 divided by 0 isn't 0.
What is
They
it?
threw that out when they were making 0 a number.
What's 0 divided by 0 then?
Undefined. Because any number divided by itself is supposed to be 1.
But
But 0 divided by 0.
Undefined, because any number divided by 0 is undefined. But if I have 0 divided by a half, that works. Okay? Fantastic. That was a lot of fun.
oh my heavens.
I guess we'll finish this up tomorrow and get through 59. 37 through 59. I guess we'll finish this up tomorrow. Hey, that was a good round. We got 5 minutes left, don't we?
Yeah.
Excellent.
Yes. Spring break.